Well, thank you, Eric, and thank you all for attending 4 p.m. It's very impressive to have you here. The subject today is private radio networks, and I think the SCE presentation very much is in sync with what I'm going to be preparing or presenting. The presenters here, myself, I'm R&D Director at Telewave IO. Bob Finch, who you all know, is CEO of Select Spectrum, who has very deep knowledge of what spectrum is available for licensing. And we also have, not in attendance here, but we have two representatives from NIST, which is the National Institute of Science and Technology, that are responsible for standards. And the last presentation we had was use standards wherever you can. And that will be my message as well in terms of private networks. So let me, before I start the presentation, what is the connection between, public safety and utilities? Both applications require the communication has to be available, it has to be secure, and it has to be reliable. So that's kind of obvious, but that's very, very key for public safety. Where public safety differs is that in most environments, the critical communication, which is called, it's voice, it's mission critical voice or mission critical push to talk. They're the kind of key uses that they have for the network. So in public safety, a first responder, whether it's fire, police, or EMS, have to respond in minutes and hours. It isn't like, hey, send me a video and I'll get back to you, or great, thank you. It is a life and death kind of decision. So that really makes the voice communication and the reliability of that absolutely critical. So that's kind of a very important point. Now for utilities, it's kind of the same thing. I mean, obviously if you have a disaster, we haven't had too many, well, I guess we have in California. It's the same sort of thing, but it usually isn't life and death necessarily, but it's getting people out to the site, reducing the number of truck rolls to get the system up and running. So in a way, it's also a critical application where voice, really the purpose is, hey, that here's a team, you're in charge, get it going, right? And then that drives the whole response. So the message for you, two takeaways. One is standards, which I think SCE did a very good job of presenting the value of that, and you'll see I'll emphasize that as well. And the second thing is the importance of reliable voice communication in the system, whether it's utility or whether it's a public safety requirement. So the way we're going to do this, I'm going to present most of it, and Bob will address and give you a snapshot of the available frequencies. It's like, hey, people throw around ban this, ban that, how do you choose? I think in the previous sessions that we've had discussions on, well, you got to do a site survey, then you got to design your system once you know the frequencies. But then the question is, what frequencies should you use? And that's where I think Bob can provide us some insights in terms of that. So let me kind of give you kind of an overview. I'll talk a little bit about Telewave IO and then also Select Spectrum, talk about public networks and some of the challenges for private networks. Then the key areas are, there'll be Select Spectrum overview, which Bob will cover. And then I'll talk about what are the new technologies that are around that utilities can learn from, and there's a big differentiation. I mean, in a way, public safety is also it's not a big market. It's a critical market, but it isn't big. And utilities are the same. Maybe people want to buy 10,000 handsets, they don't want to buy 1 million. Whereas a carrier, hey, you got 20 million users and no problem, So the trick is to leverage what the carriers do already. And that's kind of the reason for standards, implementation of standards. And then we'll just summarize. So let me, just a quick overview of Telewave. Telewave's been around for 50 years, 7,500 customers. My own background, I've had decades of experience from chips to systems. So I understand the issue there. We cover, several markets. Public safety is key, with the land mobile radio applications, utilities, mining, and transportation, and also government. So that's kind of generally the markets we serve. So let me talk about a little bit about the evolution of networks, which is, I think, for this audience, kind of you're pretty familiar with it. But what we call legacy systems are, narrowband systems, such as LMR, VHF, UHF to 700, 800. And the use cases, there's the SCADA and, P25 and so on, which are used and widely used. And there's a sense that somehow they'll become obsolete. However, if you talk to a fireman who is trapped in a basement somewhere, and you give him an iPhone or a P25 radio and choose which one you should use, I can tell you, they know. Because they know that there actually have been use cases where they've had firemen using basically an iPhone, and they didn't know didn't know that they were in trouble, right? So while there's a real evolution in broadband, which obviously is key to everything we do, there are, in certain applications, you do need that additional level of security for personnel. So in the public space, enough said, 4G, LTE, 5G is here, obviously. And we have the AMI, reading the whole suite of products and video, a lot of video capability there as well. That's actually not super necessary for either public safety or utilities, as many speakers have already addressed. It's great to have, but it doesn't solve the critical problem. So the benefits of private radio, again, you have the security, and all the other attributes of here, as far as latency and scalability and so on, which I think we've kind of discussed. Whereas with public cellular, I think SC already covered it. You kind of like, by the way, we'll take care of your needs and probably get obsoleted, and you're gonna have to pay more money. I mean, that's not unreasonable, because their business is primarily serving 20 million users, right? And you've got what, 5,000-10,000. It's not gonna happen. So, and but on the other hand, when there's a problem, the utilities and public safety, they get the brunt of the attack. Why didn't you do this? Why didn't you do that? So that's kind of where it kind of fits. So what are the challenges for private networks? There's limited spectrum, right? And that's where you need to deal with that. We can't change spectrum. You just got to figure out how to use it wisely. Then the security, obviously we've heard that already, and the harsh environments. I mean, a good, in public safety, you've got a fireman who maybe has a truck, has some access to communication, but he may need to use his LTE network, or he may need to use additional networks to allow him to communicate in a critical environment. There's also the narrowband IoT. You've heard already, just tremendous amount of information flowing through the various systems. And then the other thing is, how do you integrate legacy and the new technology. I hate the word legacy because it ain't going away, I don't think, real quickly. It's just a matter of existing versus newer technologies. How do you get the compatibility between the two? And I'll speak to that as part of the work that we're doing with NIST. And again, standardized interfaces. So this is the same tune that we heard from our friends at SCE. So these are the enabling technologies that that are forthcoming here. One of them is the basically smart spectrum, which I'll have Bob address in a bit. Then there's also software-defined radios. You'll see we have a exhibit at the tomorrow, which actually shows a software-defined radio. It's about 5 pounds, and it is fully 4G, 5G compatible. It's basically a standalone base station that you can use a regular iPhone to communicate. And I'll get into that a little bit further. And the other key thing is the legacy communication, which is LMR to broadband. And easier said than done, but we all know that that's a key challenge for all networks and private networks in particular. So the last item I want to cover is a little bit kind of further out there, is what we call network observability using AI. And it sounds kind of a bit out there, but basically data centers today are already so complex, worldwide, numerous sites where there's massive amounts of information, both on the plant and other parameters that are monitored, which is a real candidate for utilizing, they already use that, I should say, for data networks. And there's a carryover, I think, to some of the challenges for the utilities. So that said, I'd like to have Bob speak to the select spectrum offerings and some of the frequencies.
Thank you, Steve. And I'll mention now that Steve and I discussed this last night. We had a pleasant dinner outside in California, which was very good. And we both agreed that if you have questions, comments, observations as we go through this, I think there's time. We have a small but I think very knowledgeable crowd based on some of the faces I recognize. So, by all means, jump in if you have a question as we go, or if you, particularly if you think we've said something that isn't 100% correct. So we have been in this business actually with utilities for nearly 15 years. The company overall has been around for 15 years. We have a whole broadband side, public networks, wireless ISP side as well. But my focus in the business, I'm the founder, has been on private networks particularly for utilities and critical infrastructure. We represent more than 20 bands of frequencies, and many of those are useful to utilities. In this particular presentation, I'm focused more on the PLTE, and I'm really following Telewave. I think their significant interest is on the PLTE side, and Steve mentioned interest in standards, so I thought that should be the focus. But we certainly also support narrowband, wideband frequencies. We've been quite active in the upper 700 megahertz A block, for example. We mostly work for the parties that hold the licenses in terms of who our client is, but our business is really trying to develop applications, support the development. We don't do it ourselves, but we talk to the manufacturers, we talk to the consultants, we say, here's the licenses that are available, we're interested in the use cases, and to be honest, we're creating demand, right, for the licenses that we offer by helping with applications. So we're very interested in doing that. We have some of our clients will basically say, okay, if this is a new application that's not been used on this particular band of spectrum before, we'll give a special deal, like an introductory deal to create a new interest, new solution, because that will drive more applications. So as utilities, as consultants, I see Sunny out there, by all means, come to us and say, hey, here's something I'd like to accomplish. we'd like to work with you to try and find out, okay, is there a good solution? Okay, so in terms of the bands that I would mention today, these are examples. I think they're the most relevant to the most utilities that are interested in the most standardized type frequencies. Again, there'll be different frequencies. The ones in bold are licenses that we offer. The other three that are in regular font are offered by other parties. So far, one of those, by the way, band 110 at 1.4 gigahertz, 1400 megahertz, is just kind of freshly arrived on the market. It's been bouncing around. It was a satellite-oriented frequency for a long time. And now they've seen an opportunity and just announced in a recent Spectrum subcommittee meeting, hey, we're here. That's a company called Midwave. The block size there is, the maximum that's currently available. There's some complexity in band 106. People know Anterix. They've got a significant clearing issue that they're working on. So by all means, look into that. The upper 700 megahertz A block's been sold in about a third of the country, available in the other thirds. It's not true broadband, right? It's part of the 4G, 5G standards, but it only supports the narrowband IoT. Great for massive uses, not good for high broadband or low latency to a particular frequency. Band 54 we're excited about. This is Legato Networks holds these licenses. They have 5 megahertz time division versus frequency division. I think most of you know that situation. By having time division, you can allocate the entire frequency. If you have majority uplink, the vast majority, 80-90% of the capacity can be allocated to the uplink. That's common in lots of utility type applications. We just heard a presentation in the prior session from Southern California Edison. So they're doing the CBRS deployment. They bought CBRS PALs at 3.5 gigahertz. In general, I think most of the people know that the lower frequencies are going to propagate longer, right? So that's advantageous. The higher frequencies tend to have more capacity, not capacity per megahertz, but more, those bands are wider. If you get smaller cell sizes, you have to buy more sites, okay? But you also get to reuse that capacity in each site. So these are the kinds of things that really make sense to go through carefully. As we heard in the prior session, evaluate what is going on with your build and really what you're trying to accomplish. I'm going to show some band plans. I'm a graphical-oriented person. And this maybe helps to illuminate some of what's going on. So I'm going to start with the lower frequencies, upper left, 700 megahertz band plan. There's a lot of utilities in those green 1+1 megahertz, and they are supporting field area networks, and many of the utilities are pretty happy with the amount of capacity they're getting. Now, we have a push towards 5G, but it depends on the philosophy. We've had recent decisions from utilities to say, no, I'm willing to live with these wideband frequencies. I don't want to deal with the complexity of trying to operate an LTE network. That's an economical solution. It has capacity limitation. Because the propagation is good at these frequencies, it's certainly significant, and we would be glad to talk to you about those. In the 800 and 900 megahertz, it's worthwhile mentioning, so this is where Anterix is. This is where relatively recently announced Grain Management is in the process of obtaining these licenses from T-Mobile, and Black & Veatch is marketing these. They've also presented to the Spectrum subcommittee. By the way, for anybody interested in Spectrum or private wireless in general, I definitely recommend the UTC Spectrum subcommittee. So excellent propagation in these frequencies. The band 26 800 has a lot of deployed equipment, right? Because Southern Company is, well, first of all, this has been a carrier network under T-Mobile, so there's all those devices, but also Southern Company or Southern Link has a deployed network in these frequencies, so significant equipment available. Anterix has worked very hard to develop the ecosystem that's available at 900. There's still gaps, but they've made tremendous progress, and I admire what they've done there. A challenge here is, if you notice the red frequencies on either side of band 26, so that's carriers operating cellular networks. Similarly, you have other, push-to-talk and other applications going on at 900. These are relatively high noise environments. How many were here yesterday and participated in either the sessions or the cocktail hour? How many were here? Not, yeah, okay, fair enough. How loud was it after the sessions or during the cocktail hour? We were trying to have a conversation, right? And this is the same issue. It's audio waves rather than, and sound waves versus radio waves. But in these environments, there is ambient noise. And while the propagation is going to be better, you're also going to have to deal with those noise sessions. And I think we're going to try and get together a session on the subcommittee to deal with those. When Midwave announced, one of the things they pushed very hard was, hey, we're in a low noise environment, which indeed they are. There's going to be a fair amount of noise at 3.5 gigahertz too, I guess I should mention. So at 1.4 or 1.6 gigahertz, it's a very different situation. Propagation is not quite as good, but there's a very low noise environment. So when you run through all the numbers, and this requires getting pretty sophisticated engineering studies done, you may find that these low noise environments are adequate propagation, adequate distance, and in fact can deliver more capacity and could be more cost effective. So that's kind of an overall picture. I want to, as we said, Steve is going to really be leading the presentation today. Certainly take questions or comments now if there's any on Spectrum, or we can do it later. Yes, sir, in the back.
This is a really stupid question. I've always asked the question to myself. How are they coming up with these numbers, like 26 and 40? I never remember them.
It's secret code. We just try to confuse people with them. That's the objective.
The order of release is like, okay, first band is this, just like 24.
Could be the ITU.
So
this is 48, which is like double.
This comes out of the 3GPP standards group, right? Also something that has a number to it because it refers to the old generation of cellular standards. There is some logic in that you'll notice 54 and 48 are in that range that's some time division blocks, but then 103 and 106 came later and 110 came later. So I would say, assume that it makes no sense. Look it up on Wikipedia if you want to know what the frequencies, or come by our booth number 544. With that, let me turn it over to Steve. I'll be here for more questions.
Good.